Now it's time to describe another important but largely unfamiliar to most people part of the blockchain universe: private permissioned blockchains. They are different from public blockchains like Bitcoin, Ethereum, and the other projects discussed so far, mainly in one key aspect: access to the network. While in public blockchains, anyone can download some open-source software, join the network, and use it. In private blockchains, access to the network is restricted. Corporations, government entities, and other organizations can build their own private blockchains to serve their business or administrative purposes. Such private blockchains are typically more centralized and much closer to a distributed database or ledger in their architecture and functions. This is because they don't need a decentralized trust model like Bitcoin and other public blockchains. If all blockchain participants are known, have been pre-approved, and vetted, there is not much need to have complex consensus algorithms based on game theory. Network nodes can easily agree on the latest version of the blockchain database, as they all know and trust each other by virtue of being part of the same organization. As we mentioned in the previous section, public blockchains may not be suitable for everything and everyone. For many internal business processes, private blockchains may be a better option. Nowadays, the value of blockchain technology for business, government, and personal use is widely accepted around the world. Most large international banks and other financial institutions have been developing their internal blockchain projects for a few years now. Established technology companies like IBM have also joined the bandwagon. The same goes to shipping industry leaders like Maersk, which are interested in how blockchain can optimize their supply chain management. These large corporations have found that the best way to develop their blockchain projects is to cooperate in industrial alliances, consortiums, or partnerships with each other. This may involve industry incubators, where startup teams collaborate with corporations to develop solutions for industrial use. Next, we'll have a look at some of the most prominent cross-industry consortiums for blockchain development. R3 started as an alliance of 9 banks in 2015, with the aim of developing blockchain infrastructure for the financial sector. It has grown to include over 200 financial institutions in 2018. Banks reckon that blockchain technology could save them money by making their operations faster, more efficient, and more transparent. They are racing to build products using the technology that will generate new revenue, with dozens of patent applications filed for blockchain-based products by banks around the world. R3's main project is Corda, a blockchain, or as they call it, distributed ledger technology platform designed specifically for financial agreements between regulated financial institutions. The main difference between Corda and the public blockchains we are already familiar with, such as Bitcoin and Ethereum, is that Corda is based on consensus only between the parties to individual deals, rather than consensus of the entire network. Corda transactions are validated by parties to the transaction, rather than a broader pool of unrelated validators. Therefore, the entire transaction database in Corda is not copied to all network participants. This design also doesn't need a native cryptocurrency to incentivize and reward miners to validate transactions, as proof of work is unnecessary for private deployments. Corda's architecture directly enables regulatory and supervisory observer nodes. Distributed applications can be built on Corda using the Java Virtual Machine, which facilitates user adoption and interoperability with legacy systems. Notwithstanding the different design of Corda, the Chief Technology Officer, or CTO, of R3, Richard G. Brown, describes neatly the evolutionary steps that led to Corda's creation, starting with Bitcoin and giving credit to the brilliant innovation it brought to the world. Bitcoin's architecture, as I have often written, is a marvel. Its interlocking components are one of those rare examples of something so elegant that they seem obvious in hindsight, yet which required a rare genius to create. Blockchain was the tool that was invented to solve a real problem. We concluded that a blockchain such as the ones underlying Bitcoin or Ethereum, or any of the private variations, actually provide at least 5 interlocking but distinct services: consensus, validity, uniqueness, immutability, and authentication. Consensus is the first and most important feature of blockchains, and the thing that is probably genuinely new in terms of scale and scope. It allows to create a world where parties to a shared fact know that the fact they see is the same as the fact that other stakeholders see. Sure, consensus systems and replicated state machines have existed for years, but consensus systems at Internet scale between untrusting actors that work in the force of powerful adversaries, that's a step forward. In Bitcoin, the shared facts are things like, what are all the Bitcoin outputs that have not yet been spent, and what needs to happen for them to be validly spent? And the facts are shared between all full node users. Validity is about the rules of the game. It defines a clear set of rules for validating transaction. Uniqueness refers to the fact that besides following the set of rules for valid transactions, such transactions also need to be unique. In other words, no spending of the same money twice at the same time can be allowed. This is the double spending problem that Bitcoin first solved in a decentralized way. Immutability is enforced by the system, not by virtue of past transactions being immutable per se, but by the fact that other network participants will not accept a blockchain with past transaction history different than the one they personally store. Authentication refers to the design feature of all transactions being authenticated with private keys controlled by users. This eliminates the need for a central authority or system administrator, which can represent a central point of failure. The conclusion of R3CTO is that the thing that is genuinely new is the emergence of platforms shared across the Internet between mutually distrusting characters that allow them to reach consensus about the existence and evolution of facts shared between them. So if that's what this is all about, then what are the shared facts that matter in finance? What business problem would we need to have for any of this work to be of any use at all? And this is the light bulb moment and the fundamental insight driving the entire Corda project. The important shared facts between financial institutions are financial agreements such as Bank A and Bank B agree that Bank A owes $1 million to Bank B, payable on demand. This is a cash demand deposit. Bank A and Bank B agree that they are parties to a credit default swap with the following characteristics. This is a derivative contract. Bank A and Bank B agree that Bank A is obligated to deliver 1,000 units of common stock to Bank B in 3 days' time in exchange for a cash payment of $150,000. This is a delivery versus payment agreement. The financial industry is pretty much defined by the agreements that exist between its firms, and these firms share a common problem. The agreement is typically recorded by both parties in different systems, and very large costs are caused by the need to fix things when these different systems end up believing different things. Multiple research firms have postulated that tens of billions of dollars are spent each year on this problem. In particular, these systems typically communicate by exchanging messages like, I send an update to you and hope that you reach the same conclusion about the new sale of the agreement as I do. Financial institutions spend a lot of money on reconciling their books to check if all parties are indeed on the same page, and if not, they have to spend even more money to fix any inconsistencies or other issues uncovered. Then R3CTO describes the solution his project brings to the market. Now, imagine we had a system for recording and managing financial agreements that was shared across firms, that recorded the agreement consistently and identically, that was visible to the appropriate regulators, and which was built on industry-standard tools with a focus on interoperability and incremental deployment, and which didn't leak confidential information to third parties. A system where one firm could look at its set of agreements with a counterpart and know for sure that what I see is what you see, and we both know that we see the same thing, and we both know that this is what has been reported to the regulator. That's Corda. There have been plans to contribute Corda into the Hyperledger project, of which R3 is a member. Hyperledger is another enterprise blockchain development consortium which is even broader in scale and scope, with many participants from different industries. We'll look into it next.